All right. Good morning, class. How's everybody doing today?
Good morning, how are you?
Good. So, William Shatner in space today, right? He just got back, what, at 10 o'clock he landed back down. Can't believe they sent that old man to outer space. All right, let's look at exam number 14 here. So, solving using the quadratic formula. We need to put this guy into standard form. So we need to get that 35 the other side of the equation. So we have everything equal to 0. Now we can see that our A is 6, our B is negative 11, and our C is negative 35. So X is negative B plus or minus the square root B squared minus 4AC all over 2A. So we have an 11, 2 times 6 is 12, plus or minus. See, 11 squared is 121. We got a minus and a minus, it's a plus. Let's see, I'll use my calculator here. 35 times 6 times 4, 840. All over 12. We have 11 twelfths plus or minus. See, 840 and 121, 961. So let's see, what can we do with 961? It's in my calculator. I'm just going to hit the square root and see if it's an even number here. 31. This is 31 twelfths. And let's see, since these are both in twelfths, I'll go ahead and get the two separate ones. 11 plus 31 is 42 twelfths. Right? Yeah. And 11 minus 31 would be a negative 20 twelfths. So we can simplify these. Let's see, 42 is 2 times 21. And 21 is 3 times 7. 12 is 2 times 6. And 6 is 2 times 3. So this is 7 halves. And this one down here, let's see, 20 is 2 times 10. 10 is 2 times 5. 12 is 2 times 6, which is 2 times 3. So we get a negative 5 thirds. So you can leave it like this, or you can continue on to get your two separate answers here, whichever works for you. Any questions about that one? All right, let's look at number 2 then. This is already in standard form, so we see that A is 3, B is negative 5, and C is negative 7. So X is negative B plus or minus the square root B squared minus 4AC all over 2A. Let's see, we have 5/6 plus or minus the square root 25 plus let's see, 21 times 4 would be 84 all over 6. So we got 5/6 plus or minus the square root of 84 and 25, 109. Make sure I have that right. 7 times 3 times 4. Yeah. 109. Or 6. See if I can take the square root of 109. No. So that would be our solution here. Let me check this again. A is 3, B is -5, C is -7. Negative B plus or minus B squared minus 4AC all over 2A. Yeah, it looks right. Is this what y'all got? I think I got something different. Let me check. I just worked this. I think I got something else. I'm gonna have to correct my solutions. Yeah, I did. Here's what I did last time. Let's see what I did wrong, because I have a different answer here. B squared 6. Oh, I have the wrong B here. Look at that. B is 5, not 6. So I'm gonna have to fix this. Okay. I'll do that while y'all take y'all's quiz. All right, so let's look at a quiz here. This will be quiz number 15. And let's see. I left off on 128. Try to find, let's do number 19 here on page 131. So this will be your number 1. Find a number 2 here. Do number 20. There you go. Here's your quiz. Get you in your breakout rooms. Let's see, it's 10:38. So it'll be 48, 53 at 10:53. We'll come back. In the meantime, I'm going to fix my exam solutions. Sweet, thank you. All right, let's see what sense we can make out of these. At t seconds, the height h in feet of a baseball pitched into the air is given by the function below. When does the ball hit the ground? Well, it hits the ground when the height is 0, right? So since this is the height, we just set it equal to 0 and solve for the time. So -16, I'll go ahead. I like this, I'll say when h of t equals 0. So to solve this, we need to get our A, our B, and our C. Okay. I noticed on the exam when I was grading it, some of y'all wouldn't write down your A, B, and C. You just kind of pick them out of here. It's always best to write these down before you do it, because it's a lot easier to not make a mistake when you write down your A, B, and your C explicitly. All right, let's see here. So X is, well, in this case, it's T. So we have -b plus or minus the square root b squared minus 4ac all over 2a. So let's see, we got 20 over 32 plus or minus. See, 20 squared is 400 plus, use my calculator here. We have 4 times 16 times 8, 512 over 32. See, 20 over 32 is 10 over 16, which would be 5 over 8. We have the square root of 912 over 32. So 912, take the square root of that, it's a decimal. So what we're going to do here, notice there's two answers. Well, the negative one here, when we take 5/8 minus this, we're going to get a negative number, which wouldn't make sense for the problem, right? A negative time. So we only want the positive one here, but we can go ahead and write them down. Let's see. 912 square rooted divided by 32 is 0.94. So take 5 divided by 8 plus 0.94, so 1.57. This is going to be in seconds. And the other one, minus 0.94. This is a negative 0.32 seconds. This one doesn't make sense. All right, so this is our answer. That's when it hits the ground. That's when the height is 0. All right, any questions about that one? All right, let's look at number 2 here. So when Greg dives off a diving board, his height h in feet above the water is modeled by the function h of t, where t is in seconds. Find the time it will take for Greg to hit the water. So same thing here. He hits the water when his height is 0. So we take his height, set it equal to 0, and we need to solve. There's our A, there's our B, there's our C. So t here is negative b plus or minus the square root b squared minus 4ac all over 2a. So let's see, we have a positive 1530 seconds plus or minus the square root. Oh boy, what's 15 times 15? 225 plus 4 times 16 times 12, 768 all over 32. It's negative 32, right? But that doesn't matter. Remember, the plus minus makes a negative and the minus minus makes a plus. All right, so we could say minus plus here if we wanted, because the plus minus gives us the minus minus gives us the plus. But again, this is the same as that anyway, so that minus down there doesn't matter. So we have 225 plus 768, 993, 32. Some of y'all, when y'all did the test, you wrote this down, and then the next thing you wrote down was the answer in decimal points. I'd like to see this work here, okay? And preferably an answer like this before you convert it into decimal place. If you bother to convert it into decimals, I don't really need the decimal place answer. Here, it makes sense to convert it into decimal since it's a word problem. So let's go ahead and do that here. 15, 30 seconds. Minus plus is the same thing as plus or minus. Well, square root of 93 divided by 32 is 0.98. So 15 divided by 32 plus 0.98 is 1.45 seconds. And 15 divided by 32 minus 0.98 is a negative 0.51 seconds, which again doesn't make sense to have a negative time. So it takes 1.45 seconds for him to hit the water. Any questions? All right. So I think we are on page 198 in the book. So we have more word problems. I mean, one is this 128, not 198. There we go. So after t seconds, a ball is tossed in the air. The ball reaches a height of h feet given by the function h of t. What is the height of the ball at 3 seconds? Well, plug in 3 seconds into the function. 144 times 3 minus 16 times 3 squared. Ugly 5. 144 times 3. 432. And now we have 9 times 16. 144. So 432 plus 5 minus 144. 293 feet. Always put your units. So at time 3 seconds later, we're at a height of 293. The maximum height the ball will reach, well, first we have to use our vertex formula. First, we'll find the time at which it reaches its maximum height, and then we'll plug that time in. So the time when it reaches its maximum height is negative b over 2a. Let's see. A is negative 16, B is 144, and C is 5. So negative B over 2A. So yeah, 144 divided by 32 is 4.5 seconds. 4.5 seconds is when it reaches its maximum height. So to find out what the maximum height is at that time, we just plug it into our function. This gives us 144, 648, and 4.5 times 4.5 times 16, 324. So 648 plus 5 minus 324 is 329 feet. So using the vertex formula, find the maximum height there. We had to find the maximum time first, then plug that in to find the height. So find the number of seconds the ball is in the air when it reaches a height of 229 feet. All right, well, we know our height here is given by this function, right? The height's given by that function. They say, what about when the height is 229 feet? What is the time? So you set the height equal to that, and now we have to solve for t. Okay, so looking at this guy, we set the height to 229, we solve for t. To do that, we need to put this thing into standard form. So we got negative 16t squared and 144t. Let's subtract 229 from both sides. So we get minus 224 equal to 0. So now it's in standard form, and we can solve for our time here, right? Our A is negative 16, our B is 144, our C is negative 224. Okay, let's go ahead and finish this down here. All right, so we're using the quadratic formula again, but again, we set the height equal to 229 before we solve for time. So we have to get it into standard form. So we have t is negative b plus or minus the square root b squared minus 4ac all over 2a. So we have 144 over 32 plus or minus the square root. Let's see, 144 times 144 is 20,736. Minus 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 gives us a minus. 4 times 16 times 224 is 14,336. All over 32. All right, 144 divided by 32 is a 4.5. Plus or minus, all right, 2736 minus 14,336 is 6,400 over 32. 4.5 plus or minus the square root of 6,400 is what, 800? 80. 80 over 32. So 4.5 plus or minus 80 divided by 32 is a 2.5. So 4.5 plus 2.5 would be 7. 4.5 minus 2.5 would be 2. All right, so it's at the height of 229 feet at 2 different times, right? Which makes sense, because if you look at the height, it starts off at a height of 5, and it's going to do like this. So at 229 feet, you get a 2 seconds, and at 7 seconds, 2 different points of time. So that one has 2 answers. Okay, now for part D. How many seconds will it take the ball to hit the ground? All right, well, here's our height formula. It hits the ground when the height is 0. All right, so we just use the quadratic formula again. Can we do that up here? Oh. But this time it's just the height formula equal to 0 instead of equal to 229. So here our A is negative 16, our B is 144, and our C is 5. So when this thing hits the ground, it's given by negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so we got 144 over 32 again, plus or minus. 144 squared was 2736. Minus minus gives us a plus. Okay. 4 times 16 times 5 is 320 this time. Over. So 144 over 32 was 4.5. All right. This plus minus thing, if you want, you could do minus plus, but you don't have to. So 2736 plus 320, 21,056 over 32. 4.5 minus plus, same thing as plus or minus. The square root of this 21,000 thing, and then divide that by 32 is 4.53. So we have two times here. One of them is 9.03. The other one is a negative 0.03. This one doesn't make sense because it's a negative time. So it's 9 seconds, which makes sense over here. This is your negative 0.03 seconds, right? But right here, that's your 9.03 seconds where it lands. All right, any questions about this one? Fairly comprehensive problem there. Okay. Oh, there's more. Part E. Domain and range. All right. As far as domain, that's the left and the right. That's the time, right? So we're concerned with the time starting at 0 until it lands and hits the ground, right? We found that it hit the ground at 9.03 seconds. So that's our domain, our left and right, that's of interest. The range, we start off at a height of 0. And let's see, we found that the maximum height the ball reached, not that, was 329 feet. So the up and down is from 0 to 329. So that's our domain and our range of interest here, right? So domain, range. Any questions about that? That makes sense, right? All right, a ball is thrown from a height of 15 meters with an initial upward velocity of 5 meters per second. Use the function h of t, where h is in meters, t is in seconds, to find how long it will take the ball to hit the ground. Graph this function below. All right, well, it starts at a height of 15 meters. You can see, because if you plug in a 0, you're left with 15, right? So we start off at, let's see, 1, 2, 3, 4, this is 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's where we're starting off. All right, we can see A here is negative. So this thing opens downward. So it's going to look something like that. Okay. It might look like this, or it might look like this. We don't know yet, okay? We'd have to graph this function, we'd have to find the vertex first, right? Let's see. Find out how long it will take the ball to hit the ground. So let's do that first. That'll give us some point over here. All right, so we set this thing equal to 0. T squared. It's 5t plus 15 equals 0. A is a negative 4.9. B is 5. C is 15. So we have T is negative B plus or minus the square root of B squared minus 4A C all over 2A. So we have 5 over 4.9 times 2 would be a 9.8 plus or minus the square root 25 minus is a plus. Okay, we have 4 times 4.9 times 15, 294, all over negative 9.8. So 5 divided by 9.8 is 0.51 plus or minus. All right, 294 plus 25 is 319. If we square root that, we get 17.86 and divide that by 9.8, which is 1.82. And so that gives us, let's see, 0.51 plus 1.82, so 2.33, or 0.51 minus 1.82, and negative 1.31. So if we go over here, 2.33, let's just stretch this out. Let's say 1, 2, 3, 4. Let's say this is 0.5, which would make this 1, 1.5. Make this 2. 1, 2, 3, 4. This would be 2.5. So 2.33 would be 1, 2, right about here. 2.33. Okay, so we know this thing, it either looks like this, or it might look like this. We don't know what the graph looks like. We do know it connects those 2 points though. Over here, we'd have somewhere over here would be the negative 1.31, right? We're not concerned about this side of the graph though. Okay, only the graph over here. So at 2.33 seconds is when the ball hits the ground. But they want us to graph the function as well. So in order to graph this guy, let's find the vertex. So for the axis of symmetry, we got a negative b over 2a. Negative 5 over 2 times a negative 4.9, which is 5 over 9.8. 5 divided by 9.8 is 0.51 seconds. So 0.51 seconds is our axis of symmetry, which is basically right here. So to find out where our vertex is, we need to plug that into our function. So h of 0.51 is negative 4.9 times a 0.51 squared plus 5 times a 0.51 plus 15. So 0.51 times a 0.51 times a 4.9 is 1.27, and 0.51 times 5 is a 2.55. Oh, this is negative here. And plus 15. So we have 15 plus 2.55 minus 1.27. This is 16.28 feet. So this is 15, 16, talking about right here, right? So this is our vertex. This is at 2 point, no, this is at 0.51 and 16.28. Let's see here. So there's our graph. Okay, we could find out our mirror point by looking at this point, you know, to make it even more accurate. That's not necessary. So there's our graph. Any questions about that? So our y-intercept, our vertex, and our x-intercept gives us a pretty good graph. And you can use your mirror point if you want to make it even more accurate. We have a homework section where I got the last few problems. That one looks good. Astronaut problem. All right, the root method, page 133. All right, I've already mentioned this a little bit before. All right, the graph f of x is x squared minus 9 is given. Notice the graph has symmetry over the x-axis, over the y-axis, and that the x-intercepts are also symmetric. So here's our x-intercepts. They're symmetric because this thing is symmetric about the y-axis, meaning if you fold it over the y-axis, it matches. All right, so if we look at this, if we set our function f of x equal to 0, we get this, right? We could subtract a 9 or add 9 to both sides. We get x squared equals 9. Square root both sides. All right. This is what I was talking about. When you have this, you get this plus or minus. All right. Because when you look at that, you can just look and see, well, x could be either positive or negative 3. The way they do that mathematically, instead of just going straight from here to here, the square root of x squared, they write as the absolute value of x. Okay, this is the little mathematical abstraction that goes in between here and here, why you get this plus or minus. Okay, so keep that in mind. And if you graph it, notice x squared minus 9. Remember, x squared looks like this. All they did was move it down 9 units, right? Which should make sense, right? You're taking all your old y values and subtracting 9 from them. So that's why it's simply x squared, but shifted down 9 units. Right, this one, 9 minus 4x squared. So notice this one has symmetry over the y-axis too, and the x-intercepts are still symmetric. If we do the root method again, set this thing equal to 0 to find our x-intercepts, All right, we can subtract 9 for both sides. We get this. Divide by 4, and we're here. Square root both sides. Root 9 is 3, root 4 is 2. The square root of the x squared is the absolute value of x. So x could be a positive negative 3/2. Okay. Notice this guy, remember the difference of two squares? A squared minus b squared. If you factor that, that's an a plus b times an a minus b. All right, that's what you have there. 9 is 3 squared, and then we got a 2x squared. So we could factor this. This is a difference of two squares. This is a 3 minus 2x times a 3 plus 2x. If there's set that equal to 0, all you do is set each of these equal to 0. This one gives you x is 3/2. This one gives you x is negative 3/2. So you can do it by factoring or do the root method over here. Okay. So notice this would be x squared. There's your x squared. This minus took x squared and it flipped it over. Boop. This 4 here took it and stretched it vertically by a factor of 4. So instead of like this, it gets stretched, it's more like this. And then we added 9. So that's why this thing goes up here at 9. It got shifted up 9. So the minus flipped the x squared over. The 4 stretched it vertically by a factor of 4. That's why it's skinnier. And then the 9 moved it up 9 notches. All right. All right. X squared minus 12. Notice it's just like x squared. It just got moved down 12 units. Okay, so yeah, it's symmetric over the y-axis. X-intercepts are symmetric. Same thing here. If we're trying to find our x-intercepts, we set it equal to 0. We end up with x squared equals 12. Square root both sides. The square root of 12 is the same as 2 root 3. So if we do the decimal, we get approximately 3.46. All right, x squared plus 4. Notice it's just like x squared, but it got moved up 4 units because we added 4 to all of our old y values. All right, same thing here. If you set this equal to 0, you get x squared equals negative 4. And this is different, right? Because if you take the square root, you have the square root of a negative number. And what that does is that gives you imaginary numbers. So our x is positive or negative 2y. So you don't have any x-intercepts because the roots are imaginary. Imaginary roots. All right. Remember your discriminant, your what is it? B squared minus 4ac. In this case, b is 0, and then a is 1, and then c is 4. This is a negative 16. So if you take the square root of negative 16, all right, you have an imaginary number. So the discriminant is negative, so you have imaginary roots. So this thing does not cross the x-axis. All right, let's see, it's 11:30. Let's take a 15-minute break. We'll come back at 11:45. All right, class, welcome back. Let's move on here. We're now on page 135. Solve using square root method. Right over here on number 1, add 16 to both sides. Square root both sides. Square root of x squared is the absolute value of x. Square root of 16 is 4. So x is plus or minus 4. Over here, add 100 to both sides. Square root both sides. Square root of x squared is the absolute value of x. Square root of 100 is 10. So x is plus or minus 10. Not bad, right? All right. Subtract 25 from both sides. Square root. This time we have this minus in here. So it comes out as an I. The square root of 25 is 5. So x is plus or minus 5i. All right, it's a lot quicker than the quadratic formula. Let's see this one. Let's subtract 88 from both sides. So we have negative 81 square root. That minus is going to give us an I. Square root of 81 is 9. So x is positive negative 9i. Don't want to forget that I. That's critical. Okay, let's subtract 7 from both sides. This is negative 3. 4 minus 7, yeah, negative 3. Square root. Absolute value. We have square root of 3, and that minus gives us an I. So x is positive negative root 3i. Over here we'll add 4 to both sides. Square root. The square root of negative 1 is I. So x is positive negative I. All right, let's divide both sides by 6. Let's see, let's reduce this. 6 is 2 times 3, right? 90 is 2 times 45. And 45 is 9 times 5. 9 times 5. So 3 times 5 is 15. So x squared equals 15. Square root both sides. Can't really do anything with a 15 because it's 3 times 5. So x is positive negative square root of 15. Right over here, subtract 99 from both sides. Multiply by a minus 1. Divide by 4. Square root. Let's see, square root of 99. What's the square root of 99? Is there a square root of 99? Let's see. I don't know. 99 is 3 times 33. 33 is 3 times 11. So we have on top. The bottom, the square root of 4 is 2. So this, we could pull those out. We have 3 root 11 over 2. So x is positive negative 3/2 times the square root of 11. It's the prettiest we can make it. Okay, let's see. Multiply both sides by a 4/3. So this is 40. Yeah, let's simplify this thing. 12 is 3 times 4. This is 16. So square root both sides. Absolute value of x is 4. So x is plus or minus 4. Right over here, 49x squared, subtract 16 from both sides. Divide both sides by 49. I think we can reduce that. So let's see, that minus there is going to give us an I. We have the square root of 8. And the square root of 49 is 7. See, 8 is 2 times 4, which is 2 times 2. So we could pull those out. Okay. So pull those up. We got a 2 root 2 over 7 I. So x is positive negative 2 root 2 over 7 with an I. Okay, let's subtract 5 from both sides. Square root. Let's see, 12 is 2 times 6, which is 2 times 3. So we can pull those out as a single one. So x is positive negative 2 root 3. For 12, we will add 41 to both sides. Square root. 41 is a prime number, so we can't really do anything with it. So x is positive negative square root of 41. Okay, let's see. Let's add 6 to both sides. Multiply by -1. Divide both sides by 8. 24 divided by 8 is 3. Square root both sides. So x is positive negative root 3. 14, we'll add 17 to both sides. So we get a 23 here. Square root. 23 is a prime number, so we can't simplify it anymore. There's some fractions just to make it fun. So let's add 29 to both sides. Now we'll multiply both sides by 2. Now we'll square root both sides. Square root of 64 is 8, so x is positive negative 8. You can always check your work. You can always plug in your answer back into the equation to check and make sure that it's right. So over here, we will subtract 1/3 from both sides. Multiply both sides by 4/3. we got a -4/9. Square root both sides. This minus is going to give us an I. The square root of 4 is 2, square root of 9 is 3. So x is positive -2/3 I. All right, let's answer the following. In science class, students were asked to create a container to hold an egg in which they would then drop from a window. The function h of t gives the container's height in feet after t seconds. How many seconds will it take for the container to hit the ground? Well, here's the height. It hits the ground when the height is 0. So if we're going to solve this, all right, we get subtracting 25 from both sides, multiply by a -1, divide by 16, square root. So the absolute value of t is 5/4. So t is positive -5/4. We aren't concerned about the negative time, so it takes 5/4 of a second. Same like the other problems, but the function is easier to solve. We don't have to use the quadratic formula. We can simply use square root method. All right, use this equation to answer the following question. Solve it using the quadratic formula. Well, a here is 9, b is 0, c is -5. So for part A, we have -b plus or minus the square root of b squared minus 4ac all over 2a. So 0/18 is 0. So we have plus or minus. That goes away. It's just 0. Negative is a positive. Let's see. That is 20 times 9. It's 180. 20 times 10 would be 200. Over 18. See, 180 is 2 times 90, and 90 is 3 times 30, and 30 is 3 times 10, and 10 is 2 times 5. So there's 2 2s, and then 2 3s. We still got a 5 in there. So plus or minus 2 times 3, root 5. 18 is 2 times 9, which is 3 times 3. So plus or minus the square root of 5/3. So that's using quadratic formula. Root method, let's add 5 to both sides. Divide by 9. Square root both sides. Absolute value of x, square root of 5/3. So x is plus or minus the square root of 5/3. Discuss the differences between the two. Typically, the root method is going to be a lot easier. You can almost just look at the equation and write down the answer. You had a 5/9 square rooted. You gotta have a root 5, and the square root of 9 is 3. You just write down the answer, basically. But of course, when you're doing your exams and quizzes, you have to show your work. All All right, so what conditions can you use the square root method? When there's no b, basically, right? When b is 0. Because when b is 0, you subtract c from both sides, divides both sides by a, square root. X is positive, negative, square root of negative c over a every time. And depending on if c and a are negative, this may be imaginary number, it might not. So yeah, b is 0, you can use the square root method. For each of these graphs, when can you use the square root method? This one on the left is symmetric about the y-axis. Your x-intercepts are symmetric. So this one you can. This one you cannot. Okay. This one over here, it's not symmetric about the y-axis. This one b is 0. This one it is not. That b is what shifts your parabola left and right. Okay. Ax squared plus bx plus c. All right. Compared to x squared, the a stretches vertically. The c moves up and down. The b is going to shift left and right. All right. So the graph, if you're going to use the square root method, b has to be 0, which means it has to be symmetric about the y-axis. We got some homework here. Homework. All right, 139. Factor the polynomials using the greatest common factor or grouping method. In this case, if we look at this, we can pull a 10 out of there, right? We get y squared plus 1. Let's see. We're not going to introduce any imaginary numbers. That's about all we can do there. Okay. Yeah, otherwise you get imaginary numbers. 2 here, we could pull a 3 out. We can actually pull a 3t out here, right? Then we get a t plus 2, right? 3t times t is 3t squared. 3t times 2 is a 6t. So that one's factored. All right, this one, you got an x squared and an x to the 5th. If we pulled an x squared out, we have 15 minus 21x cubed. Let's see. 15 is 3 times 5, right? And 21 is 3 times 7. Notice they both have a 3 here. So let's pull that 3 out. 3x squared. Left with a 5 minus 7x cubed. All right, that's the GCF, the greatest common factor. That's our GCF. This is our GCF. This is our GCF. All right, so this one we got an x to the 4th and an x to the 7th. We could pull an x to the 4th out. Oops. We did end up with that. but that's not our GCF. Let's see what it is. 24 is 2 times 12, and 12 is 2 times 6, which is 2 times 3. 30 is 2 times 15. 15 is 3 times 5. So the best we could do, there's a 2 and a 2 and a 3 and a 3. So if we pulled those two, the 2 and the 3 out, that's a 6. Which leaves us with a 4 here. And then the 5x cubed. So we can check 6 times 4 is 24. 6 times 5 is 30. So this was our GCF, the 6x to the 4th. All right, this one. Let's see, it looks like everything here is divisible by 6. This doesn't have an x though. So let's just pull out the 6 first and see what happens. 6 times 4 is 24. And then a 6 times 5. Okay, so that's doing the GCF. What about this guy here? We should be able to break it up into 2 pieces, right? Since we have an x squared, we need an x and an x. For here and here, we need 2 numbers that multiply to give us 5, but that add to give us a -4. So what if we did a -5 and a +1? No. -1? No, that's not going to work. That would give us a +5, but we'd have a -5x and then another -x. So let me check the instructions here, if they want us to factor these yet or not. Or grouping method. Okay. So to do these, there's a trick. I need to look it up so I can remember it. A factoring trick. Rewrite middle term as a sum of 2 terms whose product is AC and whose sum is B. Okay. So this is the trick for grouping. So if we're looking at this guy, before you get here, because this did not work. Here our A is 1, our B is -4, and our C is 5. So we need to rewrite this 4x, all right, as a sum of 2 terms whose product is A times C. A times C here, 1 times 5 is 5. All right, but whose sum is B. Okay, so we need to rewrite this -4x as something plus something. And let's see here. 2 terms whose product is A times C and whose sum is B. Okay, so let's see, -4, we could have we need 2 terms that multiply to give us 5, but add to be -4. So if the only numbers that multiply to give us 5 would be 5 and 1, right? So let's look at an example. Been a while since I've done this. So let's look at this example here. We take this middle term, the negative x, and we rewrite it as negative 5x plus 4x, because negative 5 plus 4 is negative 1. Our A and our C. A is 5. C is 4. Oh, C is negative 4. So our A plus C is negative 1. But our A times C is negative 20. Y'all remember doing this? It's been a long time. Oh, to hell with it. It's just in class now. I'll review this and get it straight in my head so I can explain it better. Let's do our exam number 15. So let's go, let's see. Let's do this one for number 1. It's on page 131. And take up the whole page for that. Yeah, let's do another one of these. Little grapher. I think. Maybe there's a better word problem. No, let's do this one. I like this one. So number 9 on page 138. There we go. And the next time we'll do factoring by grouping. Any questions, folks?
Please remain on the
No,
line.
sir.
Come again?
Have a nice weekend, sir.
You too.